Hello everyone, myself Tulsiram Darwal and I done my BTech from IIT Roorkee and today I will teach you this series LCR AC circuit. This topic is very important from alternating current chapter. This particular topic is very important because questions are coming continuously in previous years from this topic. Okay. So in this topic, not only theoretical part I will teach, I will tell you very special thing what in this class we will learn that which type of questions previously asked and in coming year in this year which question can be asked, that also we will discuss. That is important for you. What the past everyone know, but what can happen in the future, that also we will understand that these are the possibilities. Okay, so series LCR AC circuit. So first of all, it is AC circuit. You all know difference between AC circuit and DC circuit. Alternating voltage is there. This voltage change its direction. What direction? Means due to this voltage current can flow clockwise and after some time it will flow in anti-clockwise or vice versa. So here it is LCR AC circuit means all are there in the circuit. Inductor is there, capacitor is there and resistor is there. Okay, I am drawing the circuit. This is resistor, then capacitor and then inductor. These are there in the circuit. This is AC voltage. We represent AC voltage like this. Okay, and AC voltage value is given V equal to V naught sine omega t. This is what, this is peak value. You all know wave equation. So in wave equation, this is what amplitude. Amplitude means maximum value or we can say peak value of voltage. Sine graph is there. Sine theta sine function is there. You know sine function, sine theta graph is like this. So here we can see that this sine function is changing its values. Here these values will tell us about direction, that this voltage is changing its direction, polarity, positive negative, it is changing its polarity. Okay, so if polarity will change means for first half cycle this is at higher voltage and this part is at lower voltage, and for next half cycle this is at lower voltage and this is at higher voltage. Means for first half current will flow clockwise and for second half current will flow anti-clockwise, right? This is the difference between AC circuit and DC circuit. Okay, here current direction will change. Now if current direction will change and this is variable voltage, so current value also changes here. Okay, so what other special things are here in LCR AC circuit? So you have to remember here 3 points, very important these are. In resistor, when AC alternating current flow in resistor, then there is no phase difference between current and voltage. When alternating current flow in capacitor, then there is a phase difference of 90 degree between current and voltage. I will tell you what is the meaning of phase difference, that also I will tell you. But here you have to remember that 90 degree current lead from the voltage. Current lead from the voltage by 90 degree. What is the sense? We will understand. In inductor, current lag by 90 degree from the voltage. So how to remember capacitor and inductor? L means lag. Like that you have to remember. And capacitor and inductor both are reverse. Because in capacitor, current is leading by 90 degree, but here current is lagging by 90 degree. Yes? Okay. In resistor, no phase difference. What is the meaning of phase difference? Understand. Actually, here we can see this is minimum value of voltage. Don't think that this is minimum value of voltage. No, it is not minimum value of voltage. This is not minimum value of voltage. Okay. This is maximum value of voltage and this is also maximum value of voltage. This is for opposite direction, opposite sense. This is for This is for clockwise current. This is for anti-clockwise current, right? So this is maximum voltage. This is also maximum voltage. Minimum voltage is this one. This is minimum voltage. This is what minimum voltage. Okay. So initially voltage is minimum. Now listen, if in capacitor current lead by voltage from 90 degree means what? When applied voltage is minimum, at that time current in the capacitor is maximum. Means current graph for capacitor will be like this. Current graph for capacitor will be like this. Voltage minimum at that time. Voltage minimum at that time, current is maximum. This is the meaning of phase difference. Okay. In inductor, reverse graph. In inductor, current lag by the voltage. Means when voltage is minimum, at that time current is maximum in inductor but opposite direction of capacitor. Otherwise we can say that first here maximum, current maximum in capacitor, voltage minimum, then voltage become maximum, then current become minimum. Okay. So current is leading. In inductor what will happen? Reverse. Here voltage is maximum, at that time current will be minimum in inductor. Now voltage is maximum, now current will be, here voltage is minimum, at this point current will be maximum in inductor. Means what is the meaning? That this time current is maximum na, so already voltage become maximum. After then current become maximum in inductor. This is the difference. So current maximum become after the voltage maximum. That's why current is lagging. But here before the voltage maximum only current become maximum. That's why current is leading. This is the difference. But it will not work. It is not useful for you. It is only for just understanding that what is the meaning of phase difference between voltage and current in alternating current circuits. Okay. Now, so here we understood that phase difference value is 90. Here also phase difference value is 90, and here no phase difference, means when current maximum, at same time voltage also maximum. Okay. These are the important points that you have to remember. Here current will lag. Here current will lag. Here current will lead. Current will lead. These are the important points. Okay. Now how we will solve this circuit? We will apply KVL. This applied voltage must be equal to voltage across resistor, that is VR, voltage across the capacitor, that is VC, and voltage across the inductor, that is VL. So this applied voltage V must be equal to VC plus VL plus VR. But now you will say, sir, same thing is in DC circuit also. Yes, same thing, but difference is what? Here vector sign we will use. Why vector sign? Because phase difference is there between current and voltage, so we will use here vector sign. Now how we will solve it? First we have to represent applied voltage direction. Suppose this applied voltage is in this direction. Applied voltage is in this direction, V naught sin omega t. Now current in resistor, no phase difference. If and how much voltage, how much VR value is how much? IR. So this VR value is IR. VC value is IR here also, but this resistance is known as XC, that is capacitive reactance, and you all know XC value is 1 by omega C. Then how much value of VL, how much voltage here? Here also IR, but this R resistance is known as XL, that is known as inductive reactance. Okay. So these all voltage we know, but current in the inductor lag by 90, so voltage also lag. So this voltage lag from this voltage by 90 degree. So this VL direction is this one. Lag means clockwise, leading means anti-clockwise. This is the difference. Okay. So how much here? I into R. R value is XL. Okay. Then this voltage IXC. So we know current in inductor lead by 90. If current lead, to voltage also lead. From this voltage, current in inductor lead by 90. So this IXC direction must be this one. Agree? Okay. Now IR. IR, current in the resistor, no phase difference. It will be in the same direction as applied. So this is the direction of IR. Clear? Okay. Like that we represent. Now resultant of these three must be equal to applied. Okay. So here three cases are possible. First case, XC can be greater than XL. Then resultant of both will be upward. Why? Because both are opposite in direction. If it is more, then resultant of both will be upward. If it is more, then resultant will be downward. And if both are equal, then both will cancel out, resultant only IR. This case is very, very important. Okay, when both are equal, then both will cancel out. So this voltage, applied voltage, becomes equal to VR because both will cancel out. Both are equal, direction opposite, so both will cancel out. That condition is known as condition of resonance in series LCR AC circuit. Is it clear? Okay. Now, if they are equal, so when they will be equal, how we understand them? So first we have to understand graph of XC, graph between XC and omega, and graph of XL and omega. You know XL value is omega L, right? So this XC decreases by increasing the frequency, hyperbolic graph will form. So graph between XC and omega will be hyperbolic like this. Okay, XL and omega both are proportional. So you all know this graph will be straight line. XL and omega graph will be straight line. Okay. Now if we combine both graph, then graph will be, this is the graph of XL and this is the graph of XC. Okay, this is XC and this is XL. You can see here for this particular frequency, both are intersecting, means both are equal. For this particular frequency, both are equal. XC and XL both are equal. So here XC and XL both are equal. So this particular frequency is known as resonating frequency. Is it clear? This is very, very important. When XC and XL both are equal, that frequency is known as resonating frequency. Clear? XC equal to XL. Now, how to find out this frequency? Very simple. Put the value of XC. XC value is 1 by omega C and XL value is omega L. Transfer omega this side, L this side. So LC equal to omega square and omega equal to root over LC. This is resonating frequency. Very, very important, this formula. Clear? Okay. Now you can see here before this frequency, XC value is more than XL value. XL graph this one, XC graph this one. So before this frequency, XC is more than XL. And after this frequency, XL is more than XC. And one more thing, difference between their values, difference between XL and XC value. So here it is more and here it is less. Here it is less, right or not? So as we approach towards the resonating frequency, then difference between XL and XC decreases. This is again important point. Or we can say we move away from resonating frequency or frequency increases, then difference between XL and XC increases. And here also we can see if frequency decreases, then this resonating frequency, so this is XC, this is XL. So here also this difference increases. The difference between XC and XL increases as frequency decreases, and as frequency increases more than resonating frequency, then difference between XL and XC increases, means both side difference between XC and XL increases. Okay. Now, if it increase, then what will impact? It will impact net current. So ultimately what you have to remember, current formula, current equation. So current equation is what? Finally, this is current equation you have to remember. This current equation is V naught by Z sine omega t plus minus phi. This is net final current equation. Why I use here plus minus phi? If XC is more than XL, then current will lead. That's why phi plus phi, current will lead. If XL is more than XC, this side, then current will lag, because current direction is along this direction, voltage this one, so current is lagging. So if XL is more than XC, then minus phi, and if XC is more than XL, then plus phi. Is it clear? Okay. How to find this phi formula is there. Tan phi formula is XC by R. When to use this formula? XC minus XL by R. When to use this formula? If current lead, or when current will lead? When XC is more than XL, then XC minus XL by R. And if minus phi is there, means XL is more than XC. For that case, here tan phi formula will be XL minus XC by R. This is L, this is C. This is C, this is L. So if XL is more than XC, then tan phi formula XL minus XC by R. And shortcut is what? As a shortcut, you can remember that tan phi formula is mod XC minus XL by R. This is ultimate formula you have to remember as a shortcut. Okay. Mod XC minus XL. Now, we taken mod here. So, if XC is more than XL, then also okay. If XL is more than XC, then also okay. You have to take always positive here. Clear? So, phi we understood. Now, Z. Z is impedance. And this impedance formula, you have to remember what? R square plus XC minus XL square. This is the formula of Z. Now you can ask, sir, it is valid for all three cases or only for particular case? This Z is valid for all. Why? Because XC minus XL square is there. So whether you write XC minus XL square or XL minus XC square, it will be same because it is square. Okay. So if they are equal, then this value becomes 0. If it is 0, then Z will be minimum. Why? Because square, this is square, it is squared, no? So this square value becomes 0, then Z will be minimum. Otherwise, in all cases, this square is non-zero. So something we are adding means Z will be more. So this Z is minimum when XC and XL both are equal. Means for this particular case, Z will be minimum. And how much? If both are equal, both will cancel out, only R. So this is equal to R. In other cases, Z value will be more than R. We can see here XL and XC difference increases. If it is increases, so Z also increases. So current decreases. If we move this side, then XC and XL difference increases. Yes, increases. So if it is increases, Z increases, current value decreases. So ultimately, what are the important points? Now I am giving you conclusion lines. Okay. So in series LCR circuit, three cases are possible. XC can be greater than XL, XL can be greater than XC, or both are equal. When both are equal, this is known as condition of resonance, and resonating frequency is omega resonating equal to 1 by root LC. This is angular frequency. If you want to find out frequency, then put it equal to 2 pi f. So this omega resonating, we understood this formula. Now if you want to find out frequency, then put it equal to 2 pi f. 2 pi fr. Fr means resonating frequency. Omega r angular frequency. Resonating angular frequency. Okay. So we understood this resonance condition. If Xc is more than XL, then tan phi phase difference formula Xc minus XL by R. If XL is more, then XL minus Xc by R. And I told you shortcut also. You have to remember tan phi equal to mod Xc minus XL by R. Which one is greater? No problem. Mod is there. Difference must, you have to take positive here. Okay. Then we discuss this Z. This Z is known as impedance. And this impedance formula you have to remember. It is root over R square plus Xc minus XL square. This formula valid for all case. Whatever is the case, for all it is valid. This one for all case. This one for all case. Okay. Now frequency increases, then resonating frequency, then also difference between XL and Xc increases. If it is increases, so Z value increases, current value decreases. If frequency decreases, then resonating frequency, then also difference between them increases. Xc and XL difference continuously increases. If it is increases, Z value increases, current value decreases. So current is maximum only when Z is minimum. Z minimum value is R and maximum current value is how much? V naught by Z. Z minimum R, so V naught by R. This is the value of maximum current. And when current is maximum, so it is only for which case? Condition of resonance. Only in that case current is maximum, and at that time, important point, no phase difference between current and voltage. Why? Because Xc minus XL becomes 0, tan phi 0, tan phi 0, then no phase difference, phi equal to 0. These are the important points. Okay. Now we will understand this particular graph also. You know, if Z graph we have to draw, then graph will be Z formula we discuss, R square plus XL minus XC square or Xc minus XL square, both are same. This Z graph with frequency is like this. Why it is like this? I already explained you that Z is minimum when frequency is resonating. At that time, Z minimum is how much? That also we discuss R. If frequency, you know, this side, these frequency are less than omega resonating, frequency is less, then Xc will be more. This side Xc will be more than XL. As frequency decreases, difference between them increases, so Z also increases. Okay. If frequency is more than, this side omega is greater than omega R, this side omega is less than omega R. So as frequency increases, then we know XL is more than Xc. And important point is that difference between them continuously increases. This difference also we understood that increases. Okay. Now, if it increases, Z increases, so we can see Z increases like this. So this is the graph of Z. Now what about current graph? So you know current value is V by R. R is nothing but impedance. resistance, similar like resistance. So reverse graph of this Z, inverse of it will be for current. So current graph will be inverse of it like this. Okay. Now here current maximum. So you know current maximum means which frequency? Resonating frequency. And this resonating frequency value we know. We know the value of resonating frequency. Okay. How much omega r value is 1 by root LC, omega r equal to 1 by root LC, we know this value. Okay. This time Z value R. Current value maximum. I is maximum. If current maximum, then power also maximum, because power equal to I square R. Here R is Z is R only, to I square R. So power is maximum. This side power decreases. Why? Because current decreases. Now here one point we can see that we get equal current for two different frequencies. You can see here this current is for this particular frequency and for this particular frequency. For two different frequency we are getting same current, right or not? So here we defined a special value of current, that is how much RMS value, IRMS. You know, IRMS is nothing but it is the peak value divided by root 2. Peak value divided by root 2, and here maximum current is peak value I naught. So for this current also two different frequencies are there. One is omega 1 and one is omega 2. Agree or not? You have to remember about these two particular frequency also. What you have to remember? First point, difference between these two frequencies, omega 2 minus omega 1. Omega 2 minus omega 1. This difference value is how much? This difference value is equal to R by L. This difference value is equal to R by L. Very important. Okay. Second point, what is the relation between omega resonating and omega 1 and omega 2? To root of omega 1 and omega 2 is equal to omega resonating. This point also you have to remember. So we understood these two frequencies. Which frequencies these are? Where current is equal to RMS current or maximum current by root 2. If current is RMS current, then power equal to 1 by 2 times of maximum power. Here power, maximum power. Here power, half of maximum power. If current become I max by 2, then power become half. Understood? Okay. Now, one more very important, very important, quality factor. Quality factor of the alternating current. This formula you have to remember. It is omega resonating by omega 2 minus omega 1. Nothing, it is nothing, just how to remember it. Quality factor, we represent it by Q, and it is nothing but it is XL by R. XL by R, you know, at the time of resonance, XC and XL both are equal, so you can write XL by R, otherwise XC by R also. XL value you know, omega L by R. This is the formula of quality factor, and we know R by L is omega 2 minus omega 1. This omega is nothing but it is resonating frequency. Okay, so you can write it omega resonating by R by L is omega 2 minus omega 1. Is it clear? So these are the important points regarding series LCR AC circuit. Now we will solve questions. Okay, and in questions you will see only I will use those particular concepts that I taught you in this class. So these are previous year questions which came in NEET exam. We will discuss few questions. All are same questions, as we will discuss 4 or 5 questions. Similar like that, other questions are there. Okay. This question, it came in which year? 2020. Okay. Now you can see here in series LCR AC circuit, what is given here? AC voltage is applied. Means it is series LCR AC circuit question. Okay. When inductor is removed, Okay, when inductor is removed, then phase difference between current and voltage is pi by 3. So you know, if inductor is removed means capacitor and resistor is there. Okay, how much phase difference? Pi by 3. We discuss phase difference formula is how much? Mod XL minus XC by R. This formula we discuss or not? Yes, we discuss. No problem. If L removed means what is there? X is there. To tan phi value pi by 3 means 60 equal to XC by R. L removed, then X is there. Next, if capacitor is removed, then what is remaining? Inductor is remaining. If inductor is remaining, capacitor removed, then tan phi value is again given. Phi is how much? Pi by 3 means 60. XL, it is there in the circuit, C is removed. So XL by R. Okay, no problem. To 1060 XL by R, 1060 XC by R. See both, this term same, R same. So XC must be equal to XL. So XC, our conclusion that XC and XL both are equal. Okay. Now what we have to find out? Power factor of the circuit. So we have to find out power factor. We understood if XC and XL both are equal means it is a condition of resonance, and that at the time of resonance this tan phi value is XC XL both are equal, both will cancel out, tan phi 0, power tan phi value is 0. Tan phi 0 means phi value is 0. Phi value 0, what we have to find out? Power factor. You know, power factor is cos phi. Power factor is cos phi. So power factor formula is cos phi, which is equal, and phi value is how much? 0. So cos 0 is how much? 1. So here power factor value is how much? 1. This formula also you have to remember. Power factor, you know, this cos phi in power formula, this term is there, cos phi. This cos phi is power factor, and which is equal to R by Z. Z already we understood. Okay, so we discuss that question. Now one more question. Suppose this question. AC voltage is applied to a resistor, inductor, and both are in series. Inductor and resistor both are in series. If R and inductive reactance are both equal to, so R value is given 3 and inductive reactance means XL 3. Both are equal to 3. The phase difference between applied voltage and the current. How much simple question it is. We discussed how to find out phase difference. Yes. Tan phi formula, XL minus XC by R. Here capacitor is there? No. So XC value 0. XC value 0. So only XL by R. Clear? Both are 3, 3. 3 by 3, 1. So tan phi value 1. Okay. So what they are asking? Phase difference. You know, tan phi 1 means, tan theta 1 means theta equal to 45. So phi value 45 degree. Here current will lag by 45 degree from the applied voltage. Understood? Now this question, it is good question. Okay, very good question, understand it. What is given? A circuit when connected to AC source of 12 volt give current of 0.2 ampere. A circuit is there. In the circuit, what is there? We don't know. Capacitor, inductor, resistor, what is there? We don't know. So suppose this is the circuit. What is there inside? We don't know. It is connected with AC voltage of 12 volt. Now remember this point. If only it is given that it is connected with AC voltage of 100 volt, 200 volt, means which value they give? RMS value. So this is which value? RMS value. Okay. How much current flow in the circuit? 0.2 ampere. This current flow. Now same circuit connected to DC source, and here also voltage is 12 volt. How much current flow? 0.4. So same circuit, this one only. The same circuit connected with DC voltage, we represent DC voltage like this. Voltage value how much? 12 volt. Current value how much? 0.4. You can see here current increases. Current increased. If current value increased, means resistance value decrease. So that same circuit produce less resistance for DC voltage. It produce more resistance for AC voltage. Means we know one thing, that capacitor and inductor, they offer resistance only for alternating current, alternating voltage, not for DC voltage. So means here if resistance is less, here resistance is more, means in the circuit capacitor is there or inductor is there. So 100% in the circuit resistor, capacitor is there, or resistor, inductor is there, or all resistor, capacitor, inductor is there. But here this current is given. You know, capacitor in DC, in case of DC voltage, after a long time capacitor become fully charged, then capacitor start to behave like open circuit, current becomes zero. But here current is there, means in the DC circuit capacitor must not be connected. So without capacitor any other, and both are same circuit, so here no capacitor, so here also no capacitor, means without capacitor any option? Yes. Which option? A. That is our answer, without capacitor. Understood? Okay. So these are the questions which came in previous year and we understood. Now we will discuss this question. It came in which year? 2010. Okay. These all questions are LCR circuit questions. Now what is given? In the given circuit, voltmeter V1 and V2 read 300 volt. Which is V1? It is across inductor. Which is V2? It is across capacitor. Both are equal to 300 volt. You know here how much voltage IXL and here IXC. So we can see here both are 300. If both are equal, means it is which case? It is the condition of resonance. We know both voltage are opposite in direction and both are equal, so both will cancel out. So this applied voltage, whatever we applied, it is only across resistor. Both will cancel out, inductor and capacitor. So how much we applied? 220. It is across the resistor. What they are asking? They are asking reading of voltmeter V3. So reading is how much? Equal to applied. It is 220. So V3 equal to 220. Okay. 220, it is given in two option B and C. Now check current. Here 2.2, here 2. So you know current, whatever current and voltage they give and ask, if only they are asking find current, means it is RMS. Only voltage is given, means it is RMS. So IRMS equal to VRMS by Z, and here for this particular case Z equal to R, because both will cancel out. It is the condition of resonance. R value is how much? 100. VRMS is how much? 220. So 220 by 100. So it is 2.2. Which option? B option is correct. Now anyone can say, sir, what is the use of 50 Hertz? No use here. Don't think that every quantity is given in the question is useful. Okay. So like that we can solve the questions. Now you can see this question also asked the quality factor. We discussed quality factor formula is XL by R, omega L by R. Clear? Okay. Now it is last question. Question number 18. So in this question, in a circuit LCR connected in series with an alternating voltage, means LCR AC circuit, frequency is F. Current lead the voltage by 45 degree. Current lead means XC is more than XL, then current lead. You agree? Yes. Then value of C, what they are asking? Value of C they are asking. One thing we know very well. What is given? Phase difference is given. So phase difference formula we know. Tan phi formula? Yes. Tan phi is XC minus XL by R, because XC is more than XL. Current is leading. Phi value how much? 45. Tan 45 equal to 1. Okay, so this is equal to tan 45 and tan 45 1. If it is 1, then R equal to XC minus XL. What they are asking? They are asking capacitance. We need XC. Transfer XL this side. So R plus XL equal to XC. You know XC value 1 by omega C. We need C. Transfer C this side, this value this side. So this C is equal to 1 by R plus XL into omega. Is there any option? They put the value of XL. No problem. XL equal to, we know omega L. So XL value we know. It is omega L. They put in terms of frequency. No problem. We know omega equal to 2 pi f. So XL equal to 2 pi f into L. Okay. So that we know. Put the value. Omega is 2 pi f. Then R plus XL, XL is omega L, omega is 2 pi f. So is there any option like this? 1 by 2 pi f, here is there, here minus, here plus. So which option? D option, plus. Is it clear? Okay. Now final conclusion of this particular lecture. So ultimately what you have to remember, 3-4 points. First point, tan phi formula, that is mod XC minus XL by R. We see in many questions came based on this formula. So in this year also, which type of question can come, in which they can ask phase difference, they can give phase difference. We have to use this formula tan phi equal to mod XC minus XL by R. Okay, next, impedance formula, root over R square plus XL minus XC whole square. Okay, and it is inside the root. This is impedance formula. If capacitor is not there, then X is 0. Inductor is not there, then XL 0. No problem. Okay. Then current value. Current value is V naught by Z. This is current value. Whatever is the Z, put that, find current. Inductor and capacitor, their current in them is opposite, or we can say voltage across them is opposite in direction. IXC in upward direction, IXL in downward direction. Both are opposite to each other. Okay, this point you have to remember. Quality factor formula, you have to remember XL by R. XL and XC both are equal at the time of resonance. So XC by R also and XL by R both are equal. Otherwise it is equal to omega resonating by omega 2 minus omega 1. Omega 2 minus omega 1 equal to, you have to remember, R by L. What is omega 1 and omega 2? It is, these are the two frequencies, different frequencies, which is corresponding to RMS current or maximum current by root 2. And corresponding to this current, power loss is half of maximum power loss. These points you have to remember. Question will come in this year also from these points only. Is it clear? Okay. So all the best to you for upcoming NEET exam. Thank you everyone for listening me.